Good morning students, welcome to my channel Chemistry with DNA. I am NAUMAN AHMAD and today we are going to discuss the remaining topics of physical chemistry in chemical kinetics for BSc part 1. Today, as you know, most of the students ask question, how do we find order of reaction from any equation? So the question is this is lecture number 14 and today the question is very important. What is the question? How do we find out order of reaction? This is the most important question. How do we find out order of reaction? So there are different ways how to find out order of reaction, but in my point of view, I have made 3 important points for finding out the order of reaction. So what are these 3 steps? Step 1, step 1, step 2 and step 3. From units of k, you can find out the order of reaction. This is the very much important. Okay, how to find out the units of k. This is the most important. And the second one, rate of reaction. From rate of reaction, you can find out. And the third one, from graph you can also. This is 1, 2 and 3. These are the 3 steps from which you can find out order of reaction. Suppose let me give you one best example for this one. Suppose how to from units of k, how do we find order of reaction from units of k. So the answer is very easy. What is the answer? What is the units of k? Unit of k is mole per liter 1 minus n and time raised to power minus 1. From this you can just find out which order is this. So this is, I just told you, this is in the previous video. You can watch all these videos from my playlist of chemical kinetics, so you need not to worry about this thing. But here our question is how to find order of reaction from the unit of k. Suppose there is one equation. Let me write that question. Let me write the question. Suppose for a chemical reaction, A is converted into B. For chemical reaction, A is getting converted into B. This is a reaction. A is getting converted into B. And the unit of k, the value of k is 1.5 into 10 raised to power minus 3 mole minus 2 liter 2, or the unit is round about second inverse. It is second inverse. So this is a question for a chemical reaction. A is getting converted into B. K is 1.5 into 10 raised to minus 3. So the question is, find the order of the reaction. Find order of reaction. So this is the question. So we can solve this question from this method. So for a question, for a chemical reaction, A is getting converted into B, the value of K. So most of the students, they are getting confused because they just see 1.5 into 10 minus 3 and they become confused. So my aim is just not to make you confused. My aim is just to make you happy while solving these questions. So from this question you can easily solve. Suppose, let me give you one hint. Suppose m mole, unit of k, that is k is equal to mole per liter 1 minus n and time inverse. Now time can be anything. It can be second inverse, day is not, hour inverse, year inverse, whatsoever. We are not concerned with that. But here, now see, this is the formula. This is formula as I have written over here as well. So now we will put these equations. Now this unit we will put over here and it will give you the answer. Now what? How can we put? As we know, if I just put this in place of n, and you just put, because this is -2. If I just put, how can we write it? Very easy. Now see, this is K, mole and liter. So we can say mole and liter -2 is and second inverse. Because if, now see, if -2 multiply with it, so it will be -2, and this -2 multiply with the liter will go in the numerator, this is in denominator, so denominator से जब ऊपर जाएगा तो it will become positive and second inverse. From here you can just simply say, just place it over here. So very easy. If 1 minus n is equal to -2, so what will be n? So bring out here 1 plus 2, so n will equal be 3. Now see, from this you can easily find the order of reaction is 3. So this reaction is third order of reaction. So this is the very easy method. You do not concentrate on the words, always concentrate on the units. You can find out order of reaction from the units. Just rearrange it and you will get the best answer. So this is step number 1, from where we can find a rate of order of reaction from units of K. So second, this is the first question. Now what about the second? This is the first method. The second method, relationship between rate of reaction and concentration. Relationship between a rate of reaction and rate of concentration. Rate of concentration. So this is rate of reaction and rate of concentration. In between these relationships you can find out that. Suppose a question is here. What is the question? Is for a chemical reaction. Suppose a question is a chemical reaction. For a chemical reaction, X is getting converted into Y. Now this is a kind of reaction in which X is getting converted into Y. It is found that rate of reaction increased. From this it is found that rate of reaction is increased 2.25. It is found that rate of reaction is increased by 2.5 times when concentration of X increased. When concentration of X is increased to 1.25 times. What is the order of reaction with respect to X? This is the question. Let me repeat the question. For a chemical reaction, X is getting converted to Y. It is found that a rate of reaction is increased by 2.5 times when concentration of X increased to 1.25. What is the order of reaction? From the chemical reaction you can easily add. Now, so what is the double of 1.25? This is 1.25 and the product is 2.25. So we can easily, the double of 1.25, the double is 2.25. So this is, from my point of view, it is easy, you can see, but let's do it in a very better way. Okay, suppose let me write it for initial concentration. Suppose for initial concentration, the R1, here the reaction is R1 and concentration is C1. This is when the reaction started, but after a time T. Now see, the initial concentration is 2.25 times of R1. 2.25 times of R1. and the concentration of X is increased 1.25 of C1. So this is a comparison. We are going to compare it. So this is very easy. So now how can we do it? This is very easy. Now this is the best way. Just compare it. Whenever you are going to compare it, you can find out the rate of order of reaction. Now see, this is simply just divide 2.25 by 1.25, so you will get the order of reaction. It will become N will be 2. This is the easiest way. And the third method is very much important, that is graph. In some of the questions you will find how to find the order of reaction. So there might be I'll be making 3 graphs in which you will find the order of reaction. Suppose this is first graph, this is second graph, and this is third graph. These are 3 types of graph I have made. Now the first is x-axis and y-axis. This is also x-axis and y-axis, and also x-axis and y-axis. This is rate on y-axis and concentration on the x-axis. So what will be the order of reaction from here? And suppose the same order is given like the same, but here concentration is on the y-axis, there is the half lifetime, and here the initial concentration A0. This is, we can say it initial concentration A0, or we can say it C0. Also you can write it. In the third one, there is log to the base E or log to the base CT. And here, this is against the time. X-axis is time. And here, suppose the graph is like this. So you can find out the order of the reaction. Like, suppose the graph is given. Now see, in this reaction here, in this reaction, A, this is A, this is B, and this is C. For A, now see, unit rate is directly proportional to K concentration of A F0. Anything, if the concentration of anything is 0, it becomes 1 multiplied 1. So rate is directly proportional to K means it is 0 order. It does not depend on the rate of concentration. So that's why it is a 0 order reaction. In which rate does not depend on the concentration, so that's why it is 0 order. From this straight line is obtained, so that straight line shows rate and concentration, because the concentration of A is 0, so that's why rate is directly proportional to the K. So this is first 0 order reaction. In this reaction, whenever there is, now see, let me revise what was our value in the previous video. You can say the value of T half for the half T for the initial concentration was 0.693 divided by K. That was the value which we derived in the previous video. You can go to my playlist in chemical kinetics. You can see that value. Now this is totally it does not depend on the does not depend on this. So that's why it is first order. This is first order reaction, because initial it does not depend on the concentration. There is no time over here. And the third one graph, now see, this is whenever there is log E or whatsoever we can say. So now see, whenever there is house, we can say also sometimes there is slope is also given. This can be slope. The slope is minus K. Whenever there is minus K, it means that there is, whenever there is log to the base E or log to the base 10 whatsoever, that should be first order. You always remember that whenever there is log to the base 10, log to the base E whatsoever, that is first order reaction. And here the reaction also be log to the base E, we can say C0, initial value can also be given. And if suppose there is log to the base 10, and whenever there is log to the base E, minus K is there, and whenever log to the base 10, the value will be minus K divided by 2.303, like the same. So first order, from this graph we can see that it is first order. So these are the three, I think you got the answer of the question, okay, how do we find out the order of reaction? There are 3 steps, from units of K, from rate of reaction, and from the graph. So very easy, you just make practices on these questions. I hope you will be enjoying this video very much. Take a very good care of yourself. Assalamu alaikum.